All right, in this video, we're going to talk about polynomials and what they are. So a polynomial is just an expression of many terms. So the prefix poly, of course, in Greek means many. So that's where that definition comes from. Standard form, the biggest exponent is always written first. And then descending order from there. So if you start with an x to the fifth, the next term should have an exponent smaller than x to the fifth. And then finally, the degree of a polynomial, which we're going to look at often here, it's the largest exponent for any one term. And in some cases, if there are multiple terms, like there's a variable of x and a variable for y in a single term, then it's the sum of the exponents. So let's go through this table and classify each of these polynomials by degree and by number of terms. So the first example is just the number 2, and the number 2 has a degree of 0. And it's 0 because there is no variable in that particular polynomial. So the degree only comes when there's an exponent that goes with the variable. The number 2 has a single term, has one term. So to classify something that has one term, we classify it as a monomial. So just some vocab here. Number 2, the degree is 1. And anything with a degree of 1 is a linear function. Again, the biggest exponent for a variable in this problem is an x to the first. There are 2 terms. Of course, those terms are negative 2x and positive 3. Anything with 2 terms is a binomial. So linear binomial. The third example, the biggest exponent is 2. So anything with a biggest exponent of 2. Anything with a degree of 2 is called a quadratic. There are 3 terms. So that, of course, is called a trinomial. 3 terms. 1, 2, 3. Then we start to repeat a little bit. Degree 3 is a cubic. And this, of course, is again a monomial because there's a single term. And the last one, degree 4, is a quartic. And this one has 4 terms. So it is literally just called a polynomial of 4 terms. So there's no name specified for anything with 4 terms or more. We're going to see this in just a second in some examples, but it's important to know you cannot add or subtract unlike terms. The only terms you can add or subtract are if the variables and the exponents are identical. So if one problem has an x to the third and the other part of the problem has an x to the second, you cannot add those terms together because even though it's the same variable, they don't have the same exponent. But when you do add and subtract like terms, you only add and subtract the coefficients. You can multiply like and unlike terms. And to do that, you multiply the coefficients, and you can multiply any similar variables. So you can multiply an x to the second times an x to the third, which we'll see here in just a minute. Finally, let's look at an application here. So the application says the number of watts of power P generated by a particular wind turbine at wind speed of x miles per hour can be approximated by the following polynomial. So remember, it always helps to maybe write out what each of these variables represents. So we have an x in this problem, and they told us x is the wind speed in miles per hour. So even though it's already written for you, it just is helpful to write it again for your sake. And then the other variable in this problem is P. And they tell us right here the number of watts of power. So the number of watts of power. So this problem wants us to estimate the power. So that means we're trying to solve for P generated by a 10 mile per hour wind. So that means this is X. This is our X value. So we're trying to find P when X equals 10. And this is a definite calculator problem, but let's show our work, at least what we're going to substitute into the calculator here in a second. Hardest part here is just making sure we get it copied down correctly on paper and in the calculator. I'm going to have to break it off on the next line. So there's what you should get as an answer, 17.6403. So that's the number of watts of power. And there's our answer.